We're going to look at conversions using the metric system, okay, and the connection between the U.S. and the metric system, okay. That's what we're going to look at today, okay. And I have a method for using or doing conversions, which I'll teach you, that basically allow us to do longer conversions in one step, okay. So that's what we're going to look at today, okay. So I'm going to give you the base unit for the metric system in terms of length, mass, all these types of things. So I'm going to put them all up there, and then we'll talk about them just a little bit. Okay, 7 base units. I'm not going to give you all 7. I'm just going to give you the 5 we'll use the most. The 2 that aren't up there have to deal with intensity of light and intensity of sound, and we won't deal with those. Okay, so those are the 5 base units that you need to know. So what a base unit is for our intents and purposes is the unit which these are most commonly measured in. Okay, the unit for which these different measurements are most commonly measured in. So anytime we measure length, we want it to be in meters. Okay, knowing what we know about the metric system, maybe just a little bit. What are other measurements for length in the metric system? Yeah. Centimeters. Yeah. Any other ones? Millimeters. Decameters, decimeters, yep, kilometers, good. Those are all versions of a meter, right? Some are smaller, some are larger than a meter, okay? What are those terms? Kilo, deci, deca, centa, what are those considered? Okay, powers of tens, yes, but they're considered a prefix, right? Those are prefixes that we attach to different units, okay? So meter could be used, grams is another type of unit that's measured for mass, that's used to measure mass, but the base unit is technically the kilogram. Do we have any idea why it would be kilogram versus gram? Gram is a really small measurement, okay? It's a really small unit for a mass. So very rarely would we have quantities of something in a gram amount, right? Usually it's going to be thousands and thousands of grams, which makes it easier for us to just identify it as a kilogram. Okay, so that's why it's there. But when we're talking in terms of our prefixes, gram is still the base, right? That's the middleman, right? And then a kilogram is then bigger than a gram, a centigram, a milligram, those are all smaller than grams. Does that make sense? We're gonna review the prefixes today, and I'll give you that. So today we're gonna take down a lot of information, and then we're gonna learn how to apply that information mathematically. So we have a couple different tables and things that we'll have to write down. Time is measured in seconds, temperature in Kelvin. Okay, have you heard about Kelvin before? Have we talked about Kelvin? Okay, a little bit. It's a temperature unit. And then the amount of substance is the mole, and we'll get into the mole more specifically in Chapter 3. Okay. So here are the metric system prefixes. And I'm going to talk to you about how I wrote this table first, and then I'm going to give you a chance to write it down. So just listen for just a second. Okay. Each of these prefixes to the left, these aren't all of the prefixes. These are the major ones that I think you should know. Okay, we don't have on there femto or some of the other bigger ones like giga. Okay, we don't have all of them on there, but these are kind of the main chunk of ones that we'll know. So these are the prefixes. This is where the base fits in. So I'm not talking base unit, I mean like the zero kind of the marker, right? Meter, gram, liter, seconds, right? Those are the regular units, and this is where they fit in the table. So anything above this means it's bigger than the regular unit. Anything that's below this is smaller than the regular unit. Does that make sense? Some of you might have learned this in a stair-step type of a pattern. Okay, I didn't learn it that way. I don't teach it that way. But if you know it that way, that's great. Okay, you're more than welcome to do that. This is how I write my chart. I always like to give the larger unit the 1. Right? And I'm going to tell how many of the smaller unit are inside of that larger unit. Rather than dealing with fractions, rather than dealing with decimal points, I like to just give the larger unit the 1, and we tell how many of the smaller unit are within that larger. Does that make sense? So that's how my table is written. So megameter is equal to 1 times 10 to the 6th, or 1,000,000 meters. A kilometer is equal to 1,000 meters, or 1 times 10 to the 3rd meters. Then we fall below this. These are all units smaller than 1 meter. So I'm going to say 1 meter is equal to 10 decimeters, 100 centimeters, 1,000 milliliters, 1,000,000 micro, and 1 billion nano. Okay? So these prefixes apply to every base unit. This could be grams, this could be liters, it could be whatever it is. My example is just in meters. Okay, are we on the same page with that table? All right, I'm going to give you a couple minutes to get this table written down. Please ask questions if you don't understand how the table is written or why it's written that way. The symbol for micro is a Greek letter. So I'm going to write it a little bit bigger. Sorry. I'll write it a little bit larger so you can see what it looks like. Micro is kind of a U with a little tail on the front. Yeah, that's what it looks like. Okay, when we find the area of something, what's the formula for calculating the area of like a simple quadrilateral? Base times height, right? Or length times width, right? So a length times a length gives us the area. So the unit for area is meters squared. Does that squared have anything to do with the number? No, it does not. Okay, so if I have a box that's 4 by 4, that means my area is 16 meters squared. This squared only applies to the unit. It does not apply to the number. Okay, sometimes people like to do that. That's not how it works. Okay, units tell us what this number is measured in. Okay, units don't have anything to do with the number itself. Okay, volume is measured in liters, like we talked about, or milliliters, sometimes a little bit more common. And this is a conversion that you might want to know. 1 milliliter is equal to a cubic centimeter. Okay, that's a conversion that, it really isn't a conversion because it's 1 to 1, right? So 10 milliliters is equal to 10 cubic centimeters, right? 100 milliliters is equal to 100 cubic centimeters. So that's just a conversion that can get us back and forth between volume of a, square substance or whatever to, kind of liquid volume, how we really think about it. Equation for density. Good. Density equals mass over volume. So technically density could be measured in kilograms per liter or pounds per gallon if you needed to in U.S. measurements, right? Those aren't the common ones, but density could be measured in any mass divided by volume type situation. Okay? This is just the most common. If temperature is not measured in Kelvin, then scientifically it's measured in Celsius, right? Nobody cares about Fahrenheit except for the United States. Okay? Degrees Celsius or Kelvin are the two ways that we measure temperature. Okay? Does anyone know how to convert from Celsius to Kelvin? Yeah, Jack?
Minus either 273 or 276 from the Celsius.
Okay, 273. So if we want to convert from Celsius to Kelvin, we do what? We add 273 to go Celsius to Kelvin. We add 273. Add 273. So this conversion is really easy. It's just an addition, right? So if I'm at 0 degrees Celsius, that means that I'm at 273 Kelvin, right? If I'm at 100 degrees Celsius, that means I'm at 373 Kelvin, okay? Do we put a degree sign before Kelvin? No, it's just Kelvin. Okay, Kelvin is one that's not red. Degrees Kelvin, it's just Kelvin. Okay? So, this way if I wanted to go backward, if I needed to go Kelvin to Celsius, what would I do? Subtract. So I would subtract 273. Okay, so if I reach absolute 0, which is when we reach 0 Kelvin, what's my temperature in degrees Celsius? Negative 273 degrees Celsius, right? So absolute 0 is equal to negative 273 degrees Celsius. Okay. Add 273 or subtract 273. Okay? So you might want to put a little star by those two conversions too, since they're not in your regular table. You will need to know how to do that. Okay? So these are your conversion factors that go between the U.S. system and the metric system. Okay, between U.S. and metric. So all of these need to be in a table. I would maybe put a star by these three. Those are your big ones that you probably will need to know. Bother with unit conversions or units in the first place. Whenever we're doing our conversions or problems in general, units need to stay with the numbers throughout the whole problem. Okay, a lot of us get to working quickly with math and we drop units when realistically they're very important. Okay, units not only show us what was measured, but units help us stay on track in terms of the order of our calculations, the placement of our numbers within our calculations. They make a difference there. Okay, so please make sure that you're being diligent with your units and carrying through the whole problem. Okay, so without a measurement or without a unit, we don't know what this number is telling us. So make sure that when you're doing problems and you give your answer, you're not just leaving plain numbers, right? Our units have to be on every answer. Okay, so no plain numbers. Need to include a unit in order to have a correct answer. So we want to convert from milligrams to kilograms. Milligrams to kilograms. Is there a direct conversion that we could go from milligrams to kilograms? Do we have a direct thing in our table to go, this many milligrams is in this many kilograms? No. What's our kind of middleman here? The base, right? So grams, right? Which would be meters if we were length, or liters if we were volume. But grams is our kind of base, right? So that means we need to go technically from milligrams to grams, and then we can go to kilograms. Okay, rather than trying to move decimals places and doing everything like that, we can put this all into one table and then we only have to do math one time. All right, that's the goal with this system. Okay, so my system is called a T-chart. And I'm not the only one that uses it. Lots of people use this system for conversions called T-chart. And what happens is you start by writing what you know. Okay, all we do is write what we know. 142.2 milligrams, and we draw our T. Okay, so now we need to think about, I want to go from milligrams to grams. Okay, and this problem is essentially going to be a big multiplication problem over a division problem. Okay, multiply and divide. So if I'm trying to cancel my units in a regular multiplication or division problem or a regular proportion, where do they need to go? Right, if my units are starting on top, where do I need to go to put them to get rid of them, to cancel them out? On the bottom, right? So we're going to go diagonal, okay, on the bottom from where we started. And I want to go 2 grams. So that's one section of my T-chart. Okay, now I go back and look at my table, and I decide which of those is the bigger unit. Grams, right? So the bigger unit gets the 1, and I tell how many milligrams are in 1 gram. Look at your chart. 1,000. Look at your chart. Milli and kilo both mean 1,000. Okay. So now I've canceled my milligram units, and right now if I were to do my problem, I would be left in grams. Is that what I want to be in? No, right? I want to be in kilograms. So we just do another conversion, right? We just do it in the same table. I want to get rid of grams, so I need to put it on the bottom. And I want to go 2 kilograms, which means it needs to go on the top. Okay, for most all of our purposes, the unit we want to end up with needs to be in the top right of our T-chart. Okay. So which of those is a larger unit? Kilogram. And how many grams are in a kilogram? 1,000. Okay, so now we've canceled grams, we've canceled milligrams. Now we do our math. So we multiply across the whole top, then divide by the whole bottom. Okay, so we multiply across the whole top, divide by the whole bottom. Okay, so try that math. Multiply across. So with a metric system, you could just as easily move the decimal place, right? Okay, that's fine. If that works for you, that's fine. But we're going to get into more complex conversions in which this chart will be a little bit more necessary. So I'm teaching you the basic right now, and then you can choose what method works best for you in terms of the metric system only. Okay? How many seconds are in a leap year? What's the one thing we have to know first? How many days are in a leap year, right? How long is a leap year? That's what we know. Okay? So how many days are in a leap year? 366 days. Okay, so we're writing what we know, and we draw our T. Okay, we want to know how many seconds. So to go from days to seconds, do we automatically know how many seconds are in a day? Probably not, right? But we can go days to hours, right? So 1 day is equal to how many hours? 24. Okay, so I'm done with days. The important part with the T-chart is that you don't do any math while you're plugging in numbers here. You're just looking at this column of my T-chart, what is equal to each other. Then the next column, what's equal to each other. Okay, if I want to go from hours to minutes, so 1 hour is equal to 60 minutes, and then minutes to seconds. 1 minute is 60 seconds. Right? You could do all of these problems individually. You could take 366 times 24, get that answer. Times 60, get that answer. Times 60, get that, right? But the reason for the T-chart is we're going to put all of these conversions into one spot. So you only have to do the math one time. That's the goal. It's all over 1, so we really don't need to do any division on that bottom. Okay, so I expressed it in both scientific notation and left it regular there. You can do either. But is that about what we had? Okay. So do we see the reason behind the T-chart? Does it make sense or not? How many centimeters are in 0.48 miles? What's the trick here? What are we looking at? A conversion between what? Metric and US, right? So we've got to have some connection between the metric system or the US. So you can do it 2 ways, right? You can do it a couple different ways. But the first thing we do is rewrite what we know. So 0.48 miles. And miles is just abbreviated MI. So we need to know how many feet are in a mile, right? Does anyone know that? 5,280. Yeah. That's right, 5,280. So if you don't know that, we're going to go miles to feet. Right? Let's talk about our path first before we get too far into it. We're going to think we have to go miles to feet, then what? Feet to inches. To inches, and then inches to centimeters, right? We could also go feet to meters, and then meters to centimeters. You could go either way, right? And we should get the same answer. So you could choose your path, and we'll see if we get the same thing, okay? So 1 mile is equal to 5,280 feet. If you don't know that, you need to write it in your notes somewhere, okay, and circle it. 1 mile equals 5,280 feet. If that's not something that you just happen to know, write it down so that we get more familiar with it. Okay, I'm going to go with the first path. So if I want to get rid of feet, where do I put it? The bottom, and I want to go 2 inches. Right? Do we understand how they're canceling? Yeah. Because we're multiplying on the top, dividing by the bottom. So when we multiply and divide by the same thing, right, they're going to cancel out. That's the reason why we put them opposite of each other. So 1 foot is equal to 12 inches. Okay, so I'm done with feet. Now I want to go inches to centimeters. Good, 2.54 centimeters. Okay, again, here we could have done it differently. We could have gone meters and then meters to centimeters. That would have worked just fine. So my inches have canceled, my feet have canceled, my miles have canceled. Now we do the math one time. Should we be expecting a big number or a small number? Large, right? We're dealing with half a mile. We want to know how many little tiny centimeters are in half a mile. Yeah, what you got?
77,248.552.
Good.
Centimeters.
Good job, Philip.
Thank you. That's just
So this one is purely metric system conversions. Okay, nanometers to kilometers. So try it on your own. I'm going to walk around. Let me know if you have any questions. When I divide by a number in scientific notation in my calculator, I have to be really careful. Okay, because if you don't use this EE button, your calculator doesn't know you're working in scientific notation. So on your calculator, above, like, I think the 7, there should be a button that has 2 capital E's above it. A second EE. Does everyone see that button? It should have 2 capital E's. It's a second function. And that means times 10 to the. Okay, so when I'm using that button, my calculator knows I'm dealing in scientific notation. So it eliminates the need to use parentheses. So when I do this in my calculator, I would do 4.24, plug this in as I'm going so you can see what's happening. 4.24 divided by 1 second EE 9, right? That's saying 1 times 10 to the 9th, and then I just do divided by 1,000. Okay, so it's just one problem, but my calculator knows I'm using scientific notation, so we get out 4.24 times 10 to the negative 12th. Okay, that EE button, which really just shows up as a capital E in your calculator, that means we're using scientific notation, so it makes your calculator know it. If you use times 10 to the caret whatever, and you don't use parentheses, it's going to mess it up, especially when we divide by a scientific notation number. Does that make sense? This is centimeters squared to meters squared. So what type of a measurement is this? An area measurement, right? An area measurement. So this is a little more complicated than just length to length, right? It's an area measurement. Okay, so 34 centimeters squared to meters squared. I'm going to write what we know. What do we know about the unit centimeters squared? What is it essentially? Good. It means centimeters times centimeters. Okay, and what does meters squared essentially mean? Meters times meters. So when we start to do our conversion, we can't just go centimeters to meters, right? That's only getting rid of one of those centimeter units. So if I go centimeters to meters, that's only really getting rid of one of those centimeter units, so that's not enough, right? If we know this is centimeters times centimeters, I've only canceled one unit. So that means I have to do it twice. That way I've canceled both units, and I end up with meters times meters, which would give me a unit of meters squared. Okay, does that make sense? So we do 34 divided by 100 divided by 100. Okay, so try this one on your own. These are both smaller than the base. But here's the deal. Just go to the base and then go back to centiliters. Right? That's the simplest way. Instead of, if you can't figure out how to move the decimal place, then just go to the base and go back. 33.4 microliters. Microliters goes on the bottom. Liters goes on the top. Liters is our middleman, right? That's the base. In 1 liter, there is 1,000,000, or 1 times 10 to the 6 microliters. So I've canceled my units there. I want to go from liters to centiliters. Liters is the bigger unit, so it gets the 1. There's 100 centiliters. So we're taking 33.4 times 100 divided by 1,000,000, or 1 times 10 to the 6th, and we get 0.00334, or 3.34 times 10 to the negative 3rd. Okay, questions there? Okay.